Hello everyone, welcome back to my channel. In this video, let us discuss about VHDL, which means Very High Speed Integrated Circuit Hardware Description Language. So this Very High Speed Integrated Circuit Hardware Description Language is used in electronic design automation to describe digital and mixed signal systems such as field programmable gate arrays and integrated circuits. So this VHDL can also be used as a general purpose parallel programming language also. Okay, next coming to the next topic, we have a design. So VHDL is generally used to write text modules that describes a logic circuit. So such a model is processed by a synthesis program only if it is a part of the logic design. Okay, a stimulation program is used to test the logic design using a stimulation methods uh, to represent the logic circuits that interfaces to the design. So this connection of stimulation modules are commonly called as a test bench. So in this VHDL stimulator is a typically an event-driven stimulator. That means each transaction is added to an event queue for a specific schedule time. For example, if a signal assignment should occur after 1 nanosecond, then the event is added to the queue for infinite time. I mean, infinitely small time step, which means the stimulation alters between two modules. Those are statement execution and event processing. So this statement execution is where triggered statements are evaluated in this event processing, where events in the queue are processed. So next we have the programming design for the NAND gate. This is the program designed for the simple NAND gate in VHDL. So here this is the blocked comment VHDL 2008. This represents AND gate program, and we also have a multiplexer program over here. So the multiplexer or MUX as it is usually called. So it is a simple construct, very common in hardware design. The example below demonstrate a simple 2 to 1 multiplex with inputs A and B. We have a sector S and output X. So note that there are many other ways to express the same multiplexer in VHDL. So here we have one example which seen here, which is X is equal to A where S is equal to 1, else B. This is the one of the program for the multiplexer, and we also have a latch template. So this transparent latch is basically 1 bit of memory which is updated when an enable signal is raised. Again, there are many other ways to express this expression in VHDL also. So next we have a D-type flip-flops program here. So this D-type flip-flop samples an incoming signal that raising or falling edge of the clock. So this simple example has an asynchronous active high rest and samples at the risking clock edge. Okay, this is the simple program for the D-type flip-flops. So the next topic we have is the levels of abstraction in for VHDL. So VHDL can be used to describe electronic hardware at many different levels of abstraction. So when considering the application of VHDL to ASCII design, okay, we have three levels of abstractions. Those are algorithm level, register transfer level, which is also called as RTL, and as well as we have a gate level. So here algorithms are unsynthesizable, and which is RTL is the input to the synthesis, and the gate level is the output from the synthesis. So in terms of timing, the differences between these three are a pure algorithm consists of a set of instructions that are executed in sequence to perform some task. So hence has a neither clock nor detailed delays. It has a neither clock or nor detailed delays. So the VHDL input may have to be constructed in some artificial way for some synthesis tools. So perhaps through the presence of an algorithm clock also. So the operation in the VHDL code can there be a synchronized to this clock. So the function stars are the main elements in this algorithm level. So coming to the RTL, this RTL description has an explicit clock, and all operations are scheduled to occur in a specific clock cycles. But there are no detailed delays below the cycle level. So a single global clock may be preferred. So retiming is a feature that allows operations can be rescheduled across these clock cycles. So RTL specifies the characteristics of the circuit by operating and the transfer of data between the registers. Okay, next we have the gate level. So this gate level description consists of a network of gates and registers instead from a technology library, which contains technology specific delay information for each gate. So the characteristics of a systems are described by logical links and the timings of properties. So these signals have a discrete logic values like 0, 1, x, z. So these gate level primitives can be used to model the design. Okay, next we have an VHDL basic elements. So here in this VHDL basic elements, we have three types of VHDL basic elements. Those are identifiers, data objects, and the data types. So let us discuss about each one individually. So first let us discuss about these identifiers. So in identifiers also we have two types. Those are called basic identifiers and extended identifiers. So these identifiers can be defined as the definition of any data type. Okay, so in this identifiers, we seen two types. Those are called basic identifier and extended identifiers. So first let us discuss about this basic identifier. So this basic identifier is composed of sequence of one or more characters. So it must begin with an alphabetic characters, which is a to means small a to small z or capital A to capital Z. So it is case insensitive. So it can contain alphanumeric and under sources also. So it cannot contain spaces. So this basic identifier cannot have a spaces. Yeah, so, cannot contain spaces. So in this basic identifier, no two consecutive underscores are allowed, and also no VHDL keyword are allowed. Next, we have extended identifiers. So in this extended identifiers is a sequence of characters written between two black slashes, which we have written between the two black slashes is defined which identified as an extended identifier. So in this, any characters can be allowed, like for example, for at symbol or percentage or dollar symbol or ash or anything, any characters can be allowed in these extended identifiers. This extended identifier is a case sensitive, and it may contain spaces and consecutive underscores also. In this, VHDL keywords are allowed. So in these identifiers, we can allow VHDL keywords. So next we have the topic called data objects. The second point of VHDL basics elements, we have a data objects. So in this data objects, we have four variables. Those are called constant, variable, signal, and file. So let us discuss each one individually. So before going into that, these data objects holds a value of a specific type. For example, if it is a variable count integer or constant count integer, it holds a specific type. Okay, so in this, let us discuss about the constant. So here the constant means this type of object can be hold a single value. That means the value cannot be changed during the time of stimulation. For example, if the constant count is an integer 5, so it cannot be changed. That means it was the value is a constant without changing. Without initializing the value will be constant. So next we have the variable. So here in the variable is this type of object hold different values at different times. So it is declared within a block process, uh, produce or function. Okay, so here, for example, if we have a variable count integer and the variable sum is in this variable count will be an integer, and in this variable sum will be integer range 0 to 100. That means if in this variable sum it will get 10. This is the variable object. And next we have a signal. The here signal means it holds the list of values that includes the current value of a signal and set of possible future values that are to be appeared on the signal. Okay. And the next we have the file. So here the file, that means this file class contains a sequence of values. That means the values can be read or write to the file using a read and write processors. Read and write procedures. Okay, these are the data objects which we see. Next we have data types. So here, data types means every data object in VHDL can hold a value that belongs to the set of values. So the set of values is specified by using a type of declarations. So by characterizing into four major categories, we have data types into four major categories. Those are scalar types, composite types, access types, and file types. These are the four types in data types. So first let us see about this scalar type. So in this scalar type, that means values belonging to these types appear in sequential order. That means these types are ordered. It has some order in it. It has some sequential order. Okay, in that first we have enumeration. That means this type declaration defines a type that has a set of user defined values consisting of identifiers and character literals also. By syntax we seen here uh, by type type underscore name is is, and that is what we have a block over there is. For example, we can write that syntax will be in the example I shown down, which is type MVL is the type name is, and we have given here some sequence. That means U O1Z. These are the some of the sequence which we given here. Next we have integer. So here the integer means these values fall within a specified integer range. That means here we have a syntax type and also the example which is given here for the integer. Next we have a physical. That means it contains values that represents measurement of physical quantity like time, length, volume, or current. So these are comes under some physical data types. Here I mentioned the syntax and also the example for the physical. And next we have a floating point. It has a set of values in a given range of real numbers representing for the data types. Here I also given some syntax and also the example for the floating point. For the next we have a composite types. So here the composite types represents a collection of values. Here we have first type which we have is an array type. That means an object of an array type consists of that it has same type of elements. Uh, it also have I mentioned here some syntax and the examples for the array type also. And nextly we have a recorded type. That means it consists of an elements of different data types. We seen here some syntax and also the example for this record type. Next, we have a topic called an access type. That means the values belonging to an access types are pointers to dynamically allocated object of some other type. Okay, here I given the example. Type PTR is access module. So type FIFO is an array for 0 to 63 and 0 to 7 of bit. This is the sum of the example for the access type. Next, we have the file types. That means a file is an object of a file types is object of file types represents files in a host environment. So here we have seen some syntax for some syntax and also the example for these file types. Nextly, we have here two different data types. So these data types are also classified as a predefined data types and also these user defined data types also. So next we have operators. So these operators, in these operators, we have an adding operator, multiplication operator, logical operators, relational and comparison operators, shift operators, and miscellaneous operators. These are some of the operators which we have seen here in the VHDL. So coming to this adding operator, first in adding operators, we have plus, minus, and end symbol over here where this symbol end is the con concatenation operator. That means it can be used for an array type or an element type also. Here we have some examples for this adding operation. As you can see here, x is equal to 1 and 1 0 double 1, so the result will be 1 1 0 double 1. So next, we have a multiplication operator. So these are the multiplication operator symbols. As we can see, slash, into, mod, or rem. So here I also given some description for these multiplication operators. That means suppose mod a by b is equal to where mod operator gives a remainder of a by b with the sign of b value. And I also mentioned for an example here. And for the rem also I given some description. That means suppose rem a by b is equal to where rem operator gives the remainder of a by b with the sign of a value. And I also mentioned an example for this multiplication operator. So for the next topic, we have logical operators. So we have 7 logical operators. Those are AND, OR, NOT, NAND, NOR, XOR, and XNOR. These are the 7 logical operators. For example, we have here an AND operator between A and B, as well as we can keep any operators, any logical operators in between A and B. So note that A NAND, B NAND, C is an illegal, which means the problem can be avoided by using this parenthesis. So that means we have to mention here that A NAND B into NAND C. We have to mention like this. So next we have the topic called rational or comparison operators. So these are some of the symbols for the rational or comparison operators. We have an equal to, greater than, equal to, less than or less than equal to. These are some of the symbols we have for the rational and comparison operators. And I also mentioned some of the examples for these rational or comparison operators also. So next we have the shift operators. So these are some of the shift operators symbols which we have SLL, that means a shift left logical. If we have SRL, that means shift right logical. If we have SLA, that means shift left arithmetic. SRA means shift right arithmetic. ROL means rotate left, and ROR means rotate right. These are some of the shift operators which we have seen in the VHDL. So our next topic will be our last topic, miscellaneous operators. So these are the ABS and for two intos. So these ABS is an absolute operator, is defined by any numeric type. That means I also given some of the description for this operator, as you can observe. So this operator is defined for the left operand to be of an integer or a floating point type, and for the right operand, which we called as an exponent of an integer type only. So here in this operator, the not operator has some precedence as an above two operators. So here we can see the not operator also in this last operator. So these are for the today's topic. As you can learn about this VHDL and the design and also the types of I mean basic elements of this VHDL also. I hope you understand this topic. Thank you.